Hey guys, this is Brian with The Endless Mission. Today we are going to take an introductory look into scripts in The Endless Mission. So this is intended as a brief introduction, especially for those who've never coded before or never worked in behind the scenes in a game engine like Unity or The Endless Mission before, really to introduce you to the basic concepts. So before we get into looking at some actual game code, I wanted to quickly go over a little bit of what I apologize will be a vocabulary lesson, but I think it's important. And some of it we have covered in other videos, but I just wanted it to be top of mind before we got into the code. So I've got our designer Greg's Starlight City game open. I actually just saved it as something called Starlight City Hack so I could mess with it on my own. And to review, everything you see in your game that's listed over here in the hierarchy, from the top level object that represents the whole game level to the avatar group, to the archer avatar, to the individual child things hanging off of it. Each one of these things, each thing that's on a line by itself here in the hierarchy is an object. You might hear those referred to as game object sometimes. But those are objects, and as we've talked about, those represent something, an entity, if you will, that's located in the game world somewhere. And we know that it's located somewhere because every object you'll see here has a transform on it. And as we know, the transform represents or contains the information about where something is in the world, that's its position, how it's rotated, and its scale relative to its normal baseline size. This transform section we see in the inspector is called a component. A component you can sort of think of as a little piece of functionality that hangs off of an object or is part of an object that enables it to be or do something specific, right? In this case, the transform component is what enables things to be located in the world. Beyond the transform component, you can see on, let's say, our archer avatar, there are a whole lot of other components down here in the components section. The very first one here is the Capitan Blackclaw component. And now, right away, that may seem a little confusing because this is our archer avatar. That's what it's called up in the hierarchy, but over here in the inspector, it's got a component on it, Capitan Blackclaw, that's named after what we know is another avatar in the game. So like, what's the deal with that? Well, the answer is this Capitan Blackclaw component is a special component created by our Endless Mission team that enables all of the functionality that is associated with the Capitan Blackclaw avatar. It's independent of the visuals of that avatar and other things about it. And indeed, though Greg, when he made this level, used that Capitan Blackclaw avatar as his base, he's replaced the visuals, he's called it something else in the hierarchy, but it's still using the basic Capitan Blackclaw component to enable things like its visual effects, and if we scroll down a little bit more, its movement settings, so on and so forth. Components can do lots and lots of things in a game. If we keep moving down, there's the one that provides health to Capitan Blackclaw. And I would assume somewhere down here, we will find, here it is. This thing called a rigid body, which is another very common type of component, which enables physics to affect an object in the game. So an object that didn't have a rigid body component, for example, would not be subject to physics. So that's component. Now, this was supposed to be a video about scripting after all, so where do scripts come in? Well, a script, in the context we're discussing it, represents the code or contains the code, or I guess is the code, that makes a component work and makes a particular component be what it is. If you look at this thing called Dash Controller, and I'll just pick it because it was the next one there, you will see, like all components up here in its heading, it has a delete icon on it. And if I were to click that, that would remove this component from the Archer avatar object, and whatever it is that this component is doing, which presumably has something to do with controlling Capitan Blackclaw's dash, because it's called dash controller, wouldn't work anymore because that component would be gone. The thing making it work would be gone. There's also this minus icon next to it, which just minimizes that component without deleting it if you want to ignore that because you want to focus on something else or have less stuff to scroll through here working with this object in the inspector. But it's the one in the middle, this gear icon, that is what we're interested in. When that gear icon is available, if you were to click on it, you would get to see the code, i.e. the script, that makes this component work. I'm not going to do that on the dash controller because it's relatively complex, not surprisingly. But what I did before I started the video was I coded up a little component of my own that I thought would be useful for illustrating some of the stuff we want to talk about. What I'm going to start by doing is adding that component to the Archer avatar. To do that, I'm going to go over to my content library, and because this is a component I created myself, I'm going to click the local button, and that has the effect of filtering it only to the local components I have saved or created on my local computer, not seeing all the stuff in the cloud-based Endless Mission content library. So there's my object rotator that I wanted, and you can see when I mouse over it, it says category is script because it's a script. That's what enables the component to work, and that's why it's color-coded red, which indicates script. To add that to my Archer avatar, all I'm going to do is left-click and drag it from the content library over to the hierarchy and drop it onto the Archer avatar object. And with that done, if I scroll down here in the inspector to the very bottom, there's a new component here, Object Rotator. That's the one I just added. Like every other component, it has some settings that it is allowing me to adjust here. So what does this component do? Well, if the name wasn't a dead giveaway, what it does is it rotates an object in the game world. In this case, it rotates it around its y-axis. So the settings that are exposed here are pretty straightforward if you know that that's what the purpose is. There's a setting for degrees to rotate, which is a number, and it has a default value of 90. So by default, this will rotate the selected object 90 degrees about its y-axis. But I could change that, right? So if I don't want it to be 90, I could say it's going to be 180 and hit enter, and now it's 180, right? We'll actually set it back to 90 for this demonstration. And then the setting below that is another number. It's rotation time. And the way I've designed this component is instead of the rotation just happening instantly, like it snaps from one rotation to another, it's going to rotate it smoothly, and it rotates it smoothly over a period of time that I set here in seconds. The default value is 1 second. I'm going to change it to 3 and hit enter because I want the effect to be a little bit more dramatic in the demonstration. The last setting we have to set, which is the first one in the list, is this object to rotate setting. And here's where I specify what it is that I want to be rotating. The inspector, because of the way I've set up this script, knows that what goes here is a reference to some other object already in the level. And that's why it's styled this way. Whenever you see like this cube icon, the word none next to it here, and this dotted line border around the field, that tells you it's going to look for a reference to an object or entity in the game world. And for the purposes of this demonstration, the thing I'm going to have it rotate is a building. So to make the reference, what I'm going to do is go over to my hierarchy, expand scene, expand environment, expand buildings, and scroll down. I happen to know which one I want. It's this one right here. And then I can left click and drag from the hierarchy right over to this object to rotate field, let go. And now that reference is set to the building that I want. And you can see now the style of that field has changed. I've now got something that says building block 2x4x4 blue instead of none. And the icon is now colored orange. So I'll save my level and we'll go in play mode and I can show you what the script is doing. The way I've set up this component is I'll just step away here. The building I've set it to rotate is this blue one right behind us. And if I hit the R key, you'll see that building rotate by 90 degrees each time the R key is pressed. And if you got your stopwatch out, I hope you would find that that rotation cycle from when I hit the key to when it stops rotating takes 3 seconds there. It's back the way it's supposed to be. So let's head back over into the editor and see what is making that component work by going in and examining the actual code of the script. To view the script itself with my Archer avatar selected, which is where that script lives as a component, I can now click the gear icon right on that object rotator component, which will bring up the code right here in the editor. For those of you who have never interacted with code before, I recognize this can be a little intimidating. Don't worry, we're going to get through it. And in particular, don't focus on trying to understand what every single line of code is doing or remembering every detail of what you see as if you're going to have to take a test on it or do this all by yourself, coding it up by hand later. You're not going to have to do that, I promise. For now, I just want you to focus on getting the gist of what's going on, especially if it's your first time seeing code before. So this code is in a programming language called C#. That looks like the letter C followed by what you might refer to as a hashtag or a number sign or a pound sign. It is not C#, it's C# is the proper way to pronounce that. I want to talk about how some of the syntactical computer sciencey code that you see here maps to some of the things you already saw either when playing the game or in the editor. So the first thing to point out is right up here at the top of our script, you can see a line of code that says public class object rotator in part. And object rotator is corresponding to the very name of my component down here in the inspector. Whatever I call it here, that's what's going to appear down here in the inspector. The very next section, which has this hashtag region inspector members, and then below that is defined by another hashtag end region inspector members. That's just a technique, that hashtag and then region is a technique for keeping your code organized that we follow. But what actually is going on in that section is you'll see some language that says serialized field, and then you will see, I'll skip to the second one, private float degrees to rotate equals 90F. And that should look familiar too, because down in our component, our second property we can set is degrees to rotate. So that corresponds to what we've defined up here. Again, anything we called this up here would appear down there. And the float part of this is telling, is what's known as a variable type. And that's telling the game engine that the thing that you're going to specify here is a number of a certain kind. It's technically a number that can have a decimal places after it. We're not using the decimals right now. We could, but we're not. The equals 90F part of it is where we define the default value of 90. The same thing is happening on the very next item, private float rotation time equals 1F. And down here, there's rotation time. But here, even though the default value was 1, as said in the code, we chose to change that to 3. We overrode the default value by manually typing that in the inspector. Going back to the very first field, instead of it being a type like float, a number that we're specifying something called an entity reference object to rotate. And just like we were talking about when we first configured that component, entity reference is the way I say, hey, I want to refer to something else, some other object in the game world. And again, just by defining that type in my code, that clues in the inspector that it's like, oh, cool, when I try to set this component up for you to see in the editor, I know to show this thing with the dotted line around it, and I know that you can drag an object from the scene right onto this field to set the reference. You get all that for free just when you do that. And this type of programming and configuration pattern is really common in making games, and it's very important to making games in the Endless Mission and Unity. Why do we do it that way? Well, what this means is that someone who was a level designer, who wasn't necessarily an engineer and didn't necessarily have a coding skill set, could still change the way this rotation was going to work. He could change how fast it was going to rotate. He could change how many degrees it was going to rotate without having to edit code, because a thoughtful engineer who created the code exposed the right settings for him up here in his inspector members. Now, that's kind of the setup part of it. So how is this code actually working to do the rotation? Well, let's think about what happened in the game logically. We pressed a key, in this case the R key, and that triggered the rotation to happen. So this section of code is what's responsible for detecting the input. What I'm circling with my mouse right now is called a procedure or a method. A procedure or method is a section of code that functions on its own and it does something. In C#, methods are defined, or procedures are defined with a name. In this case, the name is update, and I'll talk about what that means in a second. And there exist between these curly braces, which kind of give structure to the C# code. So you can see after the update name, we get an opening curly brace, and then a little bit further down, there's a closing curly brace at the same level. I've just set up those indents myself, but again, that's a very common thing in writing code that other users can read because it keeps it nicely organized. And I know everything between those two curly braces at the same level of indentation is operating as part of this procedure. Update is a very special method in the Unity game engine, and therefore the Endless Mission, which is built using the Unity game engine. The update method automatically runs every time the game engine generates a frame. And if you're a gamer, you know that that could be happening 60, 90, 100 plus times per second, depending on your hardware specs. One of the things that is very commonly done in the update method in Unity, exactly because it runs so frequently, is it's used to detect input. And that's what this very first line of code within the update method is doing. This is a conditional statement. And the way a conditional statement works is if something happens, and in this case, the thing that's I'm looking to see if it's happened is if we detect that the keyboard button R has been pushed down. If that happens, then whatever is inside the next set of curly braces here is going to occur. If that isn't detected, like we weren't pushing the R key that particular frame, then whatever's inside these curly braces will just be ignored. It won't happen. And we'll try again next frame, next time update runs. Now, what is happening when that R key is detected? Well, actually what we're doing is there's an instruction here to kick off another procedure, to kick off a different procedure. That's in computer science known as calling another procedure. I'm calling another procedure and saying, hey, you run now. Technically, I could include the instructions for that procedure right inside this same one, but again, it's considered good programming practice to be what's called modular. So you break up things into smaller functional chunks. It keeps your code easier to read, it keeps it organized, and if you have a bug in your code, it makes it a lot easier to track it down. So in general, it's good practice. There's another reason, though, I'm doing it here that's actually a little more technical and nuanced. So that's a very, very brief tour of how a procedure is working. Now, that was a technical explanation, and I wanted to give you a little bit of one of those. But the reality is, as a designer, you don't need to know anything about that to make this game work. Again, you could use this object rotator component, set its settings, and enable a whole variety of behavior. What kind of variety of behavior in your game, you might ask? Well, to close, I'll show you one other thing really quick, and I think this will be kind of fun. We had this procedure rotating a building because I thought that was a nice dramatic demonstration. But watch what happens if I change the object to rotate from a building to the entire environment of the game. And I can do that by just dragging a reference to environment from the hierarchy and replacing the object to rotate setting that I previously had. Now if I save and I go into play mode, let's see what happens when I hit the R key. All right, back in the playable game, moment of truth, let's hit the R key and check that out. The whole game world rotated kind of around my avatar. And now, instead of this just being a side-scrolling game like it originally was, I've got another degree of control. That technique isn't exactly how you would implement that kind of effect in a professional game. I mean, in reality, in a professionally made game, you probably would have, like the default Capitan Blackclaw avatar does, a mouse look rotation that would be responsible for all of that. But it's kind of fun and gives you a sense of some of the things you can do with that same script working in kind of the same way. Now, apparently the enemies are not part of that top level environment object, and they kind of go along for a ride like my avatar does when I do that. And that's certainly an unintended consequence of our script, but it's kind of fun. And so that's a brief introduction to scripting and just the tip of the iceberg of what it can do. And I am now going to run away from these big guys. Watch out.